This video covers the configuration, setup, and use of the AFS AccuTurn and PLM IntelliTurn automatic end-of-row turn feature. This feature became available with auto guidance software version 30.16. Requirements for utilizing the automatic end-of-row turn are as follows. You will need a compatible vehicle. Not all CNH vehicles are able to utilize this feature. However, additional vehicles will be added with future software releases. You will need compatible display software. You will need compatible NAV2/NAV3 and receiver software. Consult the software compatibility matrix found on the dealer portal. You will need an automatic end-of-row turn display activation. Now we will cover display setup of the automatic end-of-row turn feature. Navigate to Toolbox, AccuTurn, or IntelliTurn, depending on the branding of your display. Ensure the feature is configured to On. The first setting we will configure is triggers. Triggers are used to signal where an end-of-row turn is to be initiated. There are three types of triggers: headland, outer boundary, and end of swath. We will see how the headland trigger works while viewing the run screen. A boundary and inner headland boundary have already been created. While engaged on a line with the feature in auto mode, an automatic end-of-row path will be drawn using the inner headland as the trigger point. You can see the end-of-row turn path drawn in pink on the display. Once the machine reaches the headland boundary, the machine will begin to turn. Notice the automatic end-of-row turn icon in the status and icon area. With the headland trigger, the automatic end-of-row turning path will be drawn to stay within the headland boundary and the outer boundary. To quickly navigate to the Toolbox AccuTurn or Toolbox IntelliTurn settings page, you can select the settings button on the user-defined window that has been placed on the left-hand area of this display. We will now change our trigger to outer boundary and view how it changes our trigger point on the run screen. With the trigger point set to outer boundary, the machine will initiate the end-of-row turn at the outer boundary. Notice the end-of-row turn path is again drawn in pink. The last trigger type is end of swath. This trigger type will simply initiate an automatic end-of-row turn where an end-of-row turn was triggered on the previous pass. As we see on the run screen, the turn will be triggered at the point that the turn now was last used. The next configurable item is the turn early or turn late. This allows the operator to customize where the automatic end-of-row turn starts in relation to the trigger point. A negative distance will cause the turn to be triggered early, or before the trigger point. A positive distance will cause the turn to be triggered late, or after the vehicle crosses the trigger point. After configuring a negative distance, notice how the turn initiates much earlier than when the default value is used. The opposite is true when a positive distance is used. The next configurable item is implement compensation. This will exaggerate the turn to be wider so that the trailed implement can get back onto the line faster. On the run screen, you will notice the automatic end-of-row turn path is wider, especially on the last half of the turn. This exaggerated turn allows the implement to get back on the line sooner. Now we will talk about auto speed. By default, auto speed is configured to On. When configured to On, the automatic end-of-row turn path is calculated to compensate for the vehicle's current ground speed. When configured to Off, manual speed can be configured. When utilizing a manual speed, the automatic end-of-row turn path is calculated using the manual speed that is configured rather than the vehicle's actual ground speed. This configuration is useful for field operations where the vehicle is traveling at a high speed across the field and then abruptly slows down at the end of row turn. This will allow for consistent end-of-row turn paths to be calculated. The vehicle will follow the path well as long as the operator matches the vehicle ground speed with the manual speed during the automatic end-of-row turn. Swaths to skip give the operator the option to skip guidance swaths during the automatic end-of-row turn. This feature is useful to use if towing wide implements and a sharp turn cannot be made without jackknifing. Let's observe the path of the turn with 2 swaths to skip. Turn Now is a feature that can be added to the run screen with the AccuTurn or IntelliTurn 1x2 user-defined window. When the Turn Now button is pressed, a new window appears. In this window, the direction of the turn and the number of swaths to skip can be configured. Once the desired configurations are chosen, the operator can press Turn Now to initiate the automatic end-of-row turn. Notice that when this button is pressed, the path is plotted and the turn is initiated. It is not an immediate turn, so the operator may need to anticipate where they wish to make the turn. Minimum turn radius is one of the most important configurations in regards to the automatic end-of-row turn. This dictates the radius of the end-of-row turn path. This setting must be set within the capabilities of the vehicle. If the minimum turn radius is set to a smaller value than the vehicle's physical turning radius, the vehicle will not be able to follow the planned path, and guidance may disengage during the end-of-row turn. Let's view the end-of-row turn with the minimum turn radius increased from 20 feet to 30 feet. Notice how the automatic end-of-row turn path is now much wider. This setting may need to be adjusted and observed several times before the desired turning radius is achieved. If the setting is too wide, the automatic end-of-row turn may cross outside the outside boundary. If it is too narrow, the vehicle may jackknife with the towed implement. The default value for the minimum turning radius is 18 feet. Minimum turn radius only applies to automatic end-of-row turns. It is different from the minimum turning radius found in Toolbox Nav-S. A help menu has been included to assist the operator in making these configurations. This help menu is not intended to replace the detailed information found in the Software Operating Guide. Once all the settings have been configured, navigate to the toolbox layout and ensure that AccuTurn 1x2 or IntelliTurn 1x2 user-defined window is placed on a run screen. This window allows the operator to monitor and control automatic end-of-row turns. In order for auto guidance and automatic end-of-row turn to work properly, it is important to have the implement configured properly in Toolbox Implement. Implement width, swath width, bar distance, and implement type are all vital configurations that AccuTurn and IntelliTurn use in order to calculate the end-of-row turn path. Let's now view this feature at work and in the field. Different settings will be changed, and we will view how the dynamics of the turn are affected with the tractor and implement combination. First, let's view a turn with standard settings. Now, let's view a turn with minimum turning radius increased. For this particular tractor and implement combination, 22 feet was determined to be the optimal minimum turning radius. For this particular turn, minimum turning radius was increased to 30 feet. The machine now takes a much wider turn. The automatic end-of-row path was not able to stay within the outer field boundary. Now let's view the turn early/turn late feature. We will first watch the machine turn with normal settings. Now let's view a turn with turn early configured. In this particular turn, there was a turn early distance of -6.9 feet configured. You will notice the machine starts to turn earlier when compared to previous turns. Also notice the turn is completed closer to the inner boundary. This setting can be used when trying to get the machine to complete the turn in a small headland area. However, this will cause the operator to have less time to raise the implement so that it is ready for the turn. Next, let's take a look at implement compensation. For this feature, we will observe a four-wheel drive machine. First, we will observe the machine with standard settings. Notice that this machine is using the swath skipping feature and is skipping one swath. Now let's observe the same machine with implement compensation configured to 10 feet. Notice the tractor steers sharply to the right, then steers wider on the last half of the turn. This allows the implement to follow a straighter path onto the next guidance line. It is important to have a bar distance properly set in Toolbox Implement for this feature to work. You will notice with implement compensation set to a positive value that the first half of the turn will be tighter than the last half. With implement compensation set to a negative value, the last half of the turn will be tighter than the first half. Next, let's observe the benefits of swath skipping. Swath skipping allows for a smoother turn when operating in tight spaces with large tractor implement combinations. We will observe a machine operating with a narrow headland area skipping 0 swaths. For this field, an exterior boundary was created where the soybean stubble meets the grassy area. Notice how the machine has some difficulty staying within the exterior boundary. Now we will observe the same machine with the same automatic end of row turn settings, but with swaths to skip configured to skip one swath. Now the machine can make the turn within the constraints of the exterior and interior boundary. You recall earlier that an auto speed is configured to on by default. Auto speed allows for the automatic end of row turn path to be calculated based on the vehicle's current ground speed. AccuTurn and IntelliTurn updates the planned turn path in real time based on the changes in ground speed. In all of the previous turns we have observed, auto speed was enabled. An operator may want to set auto speed to off and configure a manual speed. Remember, when utilizing a manual speed, the automatic end of row turn path is calculated using the manual speed that is configured rather than the vehicle's actual ground speed. This configuration is useful for field operations where the vehicle is traveling at a high speed across the field and then abruptly slows down at the end of row turn. When auto speed is off, the operator must maintain a vehicle speed that is less than or equal to the value in the manual speed window. If this is not done, the vehicle will likely not follow the planned path. Let's view an example of this. For this turn, manual speed was set to 5 miles per hour. However, the tractor is traveling at a speed of 6 miles per hour. Notice how the tractor cannot stay within the exterior boundary. This has been a brief overview of AccuTurn and IntelliTurn setup and operation. For further information, consult the AccuTurn or IntelliTurn software operating guide.